Hi friends, now we will look into the summary of inferential statistics as we have done some study and some example on the inferential statistics. So let's understand, or we can say let's conclude this particular topic, right? So let's say we have a given table that is plan to purchase any particular iPhone XS Max. All right, and there is actually placed an order for Apple iPhone XS Max. Yes, and actually placed an order for Apple iPhone XS Max. No, and this is the total number. Now the first question is calculate the joint probability of the people who plan to purchase and actually placed an order. That means they also planned and actually purchased that order, right? So here you can see, if we talk about this table, here we have a plan to purchase Apple phone. If we can say yes, for yes, if they actually place, there are 400, right? And if they do not purchase, there are 100. Right. So for that we have to find the probability, or we can say the joint probability, right? So you can observe from the above table the 400 plan to purchase, right, and actually placed an order for that particular phone. So the max will become our 400 out of our 2000, because 2000 is the total. Okay, so what we'll get is, let's say we have number that is FE6, that is the number of people who planned and actually placed an order for Apple iPhone XS Max. All right, so that is our 400. Then the total we have is the 2000, right? So if we get the joint probability, or we can say if we round the value after getting that particular, so what we'll do is we will just divide 400 divide by 2000, right? And we want to 4 decimal place, up to 4 decimal place. So the joint probability of the people who plan to purchase and actually placed an order is our nothing but 0.2, or we can say 2%. All right, so the joint probability is here, it is written that. Now what it is saying that conditional probability refers to the probability of event A given information about the occurrence of another event B. So that is nothing but probability of A given B, right? And this is written in this format because next question will be based on this conditional probability, right? So here you can see that this is the formula, that probability of A given B is written as P of A given B, and if we solve this we will have probability of A and B divided by probability of B. Okay, where probability of A will be our marginal probability, right, that is of A, and probability of B will be our marginal probability of B. So now it is asking that find the joint probability of the people who plan to purchase and actually placed an order. Given that people plan to purchase, right? That means they plan to purchase and actually placed an order. But here we have is the third statement, that is given that people plan to purchase. All right, only if they plan to purchase, then they purchase the order. So if we check this here, P1 as above, we can see that it is actually placed an order divided, given that plan to purchase. So P1 is nothing but the probability that actually placed an order given that plan to purchase, right? In this way we'll get that, where P2 will be our plan to purchase and actually placed an order. P3 will be our plan to purchase, right? So these three terms will be included for this value. So if we check, what we have is probability of actually placed an order. So actually placed order by 400 people, right? And if we get the probability of 400 out of 2000, it will calculate that. But we have already a statement that is given that people plan to purchase. So how many people plan to purchase that order? So there are total 500 people. Okay, and the if the total 500 people who plan to purchase an order and actually placed an order, right? So here this is nothing but we need to get the probability of B as well. So how is the total will be? Our total will be if we conclude plan to purchase that Apple phone, the total is 500, and the total whether they planned or not planned to purchase that, the total is 2000. So it will be 500 divided by 2000. So actually we will get that probability of actually placed an order given that plan to purchase an order is 0.8, because the total we had was 500 who just planned to purchase, and here it is not stated that whether they purchased or not, right? So the total for them it will be our 500 divided by 2000. Now let's move forward with the binomial distribution. So it is actually a widely used probability distribution for discrete random variables, right? Players major role in quality control and quality assurance function. Okay, so this is the function that we will have. So we will try to understand it in a more simpler method, right? So there are some important function in Python for binomial distribution that are probability mass function, that is PMF. We have discussed it many times, which is in scipy stats.binom, right? I mean, we get PMF from there. That basically gives the probability mass function for the binomial distribution binomial, right? Which is nothing but the scipy stats binom.pmf, right? Or we can say we pass the KNP for that PMF function, where K is an array and takes value in 0 to n, right? And N and P here in that function are shape parameter for the binomial distribution, right? So the output binomial this gives probability of binomial distribution function in terms of array. Now we have is cumulative density function, CDF. So basically we get it for cumulative binomial, right? And here we are storing in that variable. So we write it like this: scipy, in that we have stats, in that we have binomial, and we call just CDF. Again we pass KNF, right? So again KNF is the same value that we have here is K is integer of n number, and an NPR say parameter for this CDF function. Now which basically gives the cumulative binomial distribution. Okay, so the output this binomial will give cumulative probability of binomial distribution function in terms of array. And next thing we have is the plot, the binomial distribution function. So we use them together. So the function matplotlib.pyplot, in plot we pass K, again K is the same value, and we pass binomial, right? So this could be our binomial that we get from PMF, and we write it as order hyphen. So that is nothing but which the total syntax will gives us a plot of binomial distribution function. So let's understand with one more example, that is a LED bulb manufacturing company regularly conducts quality check at specified period on the product in manufactures, right? And historically the failure rate for LED light bulbs that the company manufactures is 5%. Suppose a random sample of 10 LED light bulb is selected. Okay, so what is the probability that none of the LED bulbs are defective? All right, exactly one of the LED bulbs is defective, two or fewer LED bulbs are defective, and three or more LED bulbs are defective. So let's say we import our necessary library, that is import numpy as np, import pandas as pd, import scipy stats for statistics, and matplotlib again for plotting our graph or visualize them, and math for all the mathematical operations, right? So here we are getting P is nothing but failure rate for LED light bulb that the company manufactures is 5%, right? So as in the question it is telling that the manufacturer rate is 5%. So here we have given that P. N is our sample size. So sample size is nothing but the suppose that the random sample of 10 LED, right? So we will get the N for random number, and we will get that K of those quantiles, right? So how we will get those 10 random number from 0 to 11? Now if we apply binomial, so again to do that we will call the PMF function, probability mass function, and passing k and p. So this way we will get our k and p's value. So if we print the binomial, right, so this will be our calculation of PMF function. And for the first question, none of the LED bulbs are defective, right? So that means the value will be at 0th position, because that is not in our count from 1 to 10, right? And the probability of that is the 0.59, or we can say 59%. So instead of calling the whole function, that is a PMF function, if we do that mathematically, so we can also get the same by using that formula, this one, the formula we have. So PMF is nothing but that makes it more easier. But if we want to calculate manually, what we'll get is, we will call that math dot factorial of n, right, and divided by math dot factorial of x multiplied by math dot factorial of n minus x, that we have our n x, right. And what we are doing is, we are multiplying, that is p to the power x, and again multiplying that 1 minus p, because to get that all LED defective bulbs, right, and to the power n minus x. So this expression is nothing but a short of this formula, n minus e, here you can see. So you can also calculate like that, and which will give us the same value, right? So the next question was that exactly one of the LED bulb is defective. Again, exactly one means we will get the first element, right? So if we get the binomial of 1, so we will get that value, which is nothing but exactly one of the LED bulb is defective, that the probability is 0.31, right? And we can also calculate using the same formula. You can try in your notebook, or you can understand it by from here as well. Now to answer the question C, 2 or fewer of the LED bulbs are defective. So here what we need is, we need the cumulative probability, right? Because cumulative probability up to 2, okay, because we need to know that up to 2 bulbs are being defective or not. Okay, now if we get that cumulative function, so we call the CDF, cumulative density function, passing k and p. And if we get that list, so here you can see that we will get the value. So for 2 or fewer of the LED bulb are defective, what we will get is, we will get the second 0, first, so 2. And here the 98% we can tell that 2 or fewer of the LED bulbs are defective, means the at most 2 the LED bulbs are defective, that the probability is 98%. Okay, and to get that same again for CDF, what we have is, we have a different way to get it, right? Because the value could be from 0 to 2. So we have defined the range, that is at most 2. Okay, y is our 0. If I in x, so what it will do is, it will calculate our CDF, right, and keep adding that into y. So at last we will get the y, that is 98%, that just we got from CDF function. Now we have the fourth question, and to answer this, there are 3 or more of the LED bulbs are defective. So what we need is, we need to subtract the cumulative probability up to 2 defective bulb from 1. Okay, because again the term more of any particular number is there. So what we will do is, first we will get the probability, that 1 minus cumulative binomial of 2. So again at the third position, what we will have is, we will have more than 3 or more than 3 bulbs that are defective. So 3 or more of the LED bulbs are defective, that is the P. Okay, so here you can see that, and we normally get it from here as well also, because why we have also printed, that is at most 2, right? So at the second what we'll get is, we will subtract it and round it. Now if we plot the binomial distribution function, so again simply, as I have said that in the plt.plot we pass k plt, right? So here you can see that this is nothing but the shape that we will get for each point, and here you can see that for the above binomial we will get this plot. So this way we plot this. Now let's move forward with the Poisson distribution. So this discrete distribution which also plays a major role in quality control, right? So the Poisson distribution is a discrete probability distribution for the counts of event that occur randomly in a given interval of time or space. Okay, so in such areas of opportunity there can be more than one occurrence. In such situations, the Poisson distribution can be used to compute probability. So example include number of defects per item, number of defects per transformer produced. So here is a note that the Poisson distribution help to predict the arrival rate in a waiting line situation, right? So where a queue is formed and people wait to be served, and the service rate is generally higher than the arrival rate. So this is the probability for the Poisson distribution. You can check out them. Okay, so we will take one example, that is a life insurance agent sells on an average 3 life insurance policies per week. Okay, and use the Poisson law to calculate the probability that in a given week he will sell some policies, right? And he will sell 2 or more but less than 5 policies. So here the lambda here the gamma value we have given is 3. So the rate is the 3, that is nothing but the 3 life insurance policies per week, which will become our mean in this case. And n is our number that we can see the random number. So let's take a random number of NP range of 0 to 16, right? For example, now what we'll do is we will get the CDF cumulative density function for the Poisson distribution, right? And which is in Poisson CDF. Now we will pass the n rate here. So if we get the cumulative Poisson, so here what we will get is a list of array. So here you can see that the first question was the probability that the agent sell some policies. So what will be the probability for some? That means we will minus that from 100% or from 1, right? And the value is our 0. So if we exclude 0, so the rest policy will be our will sell. Okay, and next question is agent sell 2 or more but less than 5 policies. So to get that we have two different things. One is 2, let's say P1 be the probability that the agent sell more than 4 policies, right? So now more than 4 policy, that means the less than 5 policies. So whether it is less than equals to 4 or greater than 5, so both are same, whether it is greater than equals to 4 or it is less than 5. Okay, so both are same. Now we will get the cumulative Poisson for 4. So here what will happen is, because we are getting x that is our greater than equals to 4. Okay, and let p be the probability that the agent sell more than 2 policies. So the second we will get if the p2, that is the probability that the agent sell more than 2 policies. So if we write this, so it will give the greater than equals to 2. Okay, so the if we get the p1 minus p2, so it will return us the probability that the agent will sell between 2 and 5, because here we have give the minimum 2 and maximum we are giving is 5. All right, so the probability that the agent sell between 2 and 5 policies will be our 0.39. Now plot a Poisson distribution function. So again, to plot that we will call the CDF from the Poisson, right, passing the n rate, and here it will return that probability distribution function of this Poisson variable. Next question is it is asking to compute binomial probability for service at a fast food restaurant. So what is the context is the accuracy in taking order at a drive-through window is important for fast food chains. So periodically QSR magazines published the drive through performance study. So order accuracy, that measure the percentage of order that AR3 filled correctly, right? So in a recent month, the probability of order filled correctly at Wendy's was approximately 86%. So suppose that you go to drive through window at Whitney's and place an order. Two friend of yours independently place order at the drive through window at the same Whitney. So what are the probability that all three, that none of the three, and that at least two of the three order will be filled correctly? So let's understand it here. So what we have is, because there are three order and probability of a correct order is 0.86, right? So using binomial distribution equation, so we will get that probability of x equals to 3, right? Given that n equals to 3 and the pi that we have given is 0.86. okay, so what we will get is, we will get the 3 factorial, right? If n is 3, so again 3 factorial into 3 minus 3, that whole factorial, and multiplying that with that pi values, right? And with the power 3, so that is nothing but the formula that we have defined above. So it is just the expression of that formula. So likewise, the calculate of x will be our 0 and calculate of x will be our 2. So if we get 0th value and if we get 2th value, so the probability of x greater than equals to, that will be equals to the probability x equals to 2 and the probability x equals to 3, which will return the 0.95%, or which will return that 0.95, which is a 95%. So to conclude that the probability that all the three order are filled correctly, and that is the 0.65. okay, so this is the value, and the probability that none of the order are filled correctly, that is 0.023. so these are do not filled correctly, which is 23%, and the probability that at least two of the three are filled correctly is 95.24%, this one. So now we have another question is related on business statistics course, right? So here what it is saying, that calculate probability based on the Poisson and normal distribution. So we will have both term together. So at the conclusion of the course in business statistics, a group of management students set for a written examination. The result throw up the following information. So here marks obtained have a mean of 60 and a standard deviation of 12. There were 300 students who wrote the exam, right? The pattern of marks follow a normal distribution. So what is the percentage of student who score more than 80 marks, right? So let's use the G table that we have earlier, and given the area between 0 and positive, so we will get the G value, right? And the proportion of a student who score more than 1.67 is 0.5 minus the proportion scoring between 0 and 167. So it will return us that the around 4.75% of the student that will score more than 80 marks. Similarly, what is the percentage of student who score less than 50 marks? So to get that less than value, again we will have 50 minus 60 here, right? Because 60 is our mean value, okay, and applying the property of symmetry, the area up to 0 minus 0.83 is same as area more than 0.83. So in the Poisson side, as before, it is 0.5, that will be minus area between 0 and 0.83. So that will be nearly 20% of the student will score below 50. Similarly, the third is, what should be the distinction mark if the highest 10% of students are to be awarded distinctions, right? So graphically method can be used for convenience. Again, we will apply the same thing, but here what we will do is, we will get the Z value, and we need to look at a normal table in inverse manner, right? So that is the value of Z. The area that will be between 0 to Z. Z is nothing but our 0.4, and this is to be seen from the table, all right, that we had. And the z value that will make the area 0.04 is 1.28. Okay, but here one thing to consider is g is our x minus 6 divided by 12. Okay, so because we also have the standard deviation of 12, so hence it will become 1.28, right? So if we simplify that x, it will be around 75.36, and this is the distinction mark that will be scored by 10% of the student. So for this particular example also, you can do some note work, right? In the notebook you can try to calculate this and match the answer here. And if there is anything I can do, please let me know in the comment box. I'll definitely reply. Thanks.